Hi students, so now I am going to start continuity and differentiability topic of your second year syllabus. Already I have discussed how many marks are going to come from this and how many type of questions are going to be asked in part E and part D. So please remember that particular things while watching this video. Okay, then one more thing, if you want notes, you pause the videos whenever you want the notes, you pause the videos, you write down it and again you play the video so that you can get complete written notes from this video. Okay, let us start with continuous function. Here a function f of x, is said to be continuous if and only if limit extending to a f of x equal to f of a. Clear? That is, a function is continuous if and only if left hand limit is going to be equal to right hand limit, and that is going to be equal to your f of a. Then we say that this function is continuous at point A. Clear? So make sure that this particular continuous function definition is perfect before going to the problems. So continuous function say that a function is going to be continuous if and only if the limit exists and it is equal to f of a. So please take this note by pausing the video. Okay. Example 1. Let us choose one of the function f of x equal to 2x plus 3 and let us check at x equal to 2 it is going to be an continuous or not. So before going to continuity, make sure that you are perfect with the methods of calculating limits, that is rationalization, factorization, substitution method and many other things which I have discussed in previous videos. So make sure that you are perfect with those things, so that because we are going to take a help of those things in this particular video or this particular chapter. Okay, we have to calculate f of x equal to 2x plus 3 at x equal to 2 is continuous or not. For that reason, let us calculate limit at x tending to 2x plus 3, because here this is polynomial function and it is not a special type of function like greatest integer, least integer, modulus, signum or not of that kind. So we not need involve substitution method. So let us go for directly putting the values of x equal to 2. So that 2 into 2 plus 3 it will be 7. So limit extending to 2x plus 3 is going to give you 7. Then what is f of 2? That is 2 into 2 plus 3. That is going to be equal to 7. So f of 2 is nothing but your f of a. This is nothing but your limit extending to a f of x. As we all discussed in the definition, limit extending to a f of x must be equal to f of a. See here, limit extending to 2x plus 3 is 7, f of a is also 7, that means f of 2 is also 7. So our definition satisfies, so that we say limit exists for f of x at x equal to 2, that is limit exist at x equal to 2 for 2x plus 3. I think you got what I have explained here. That means first you have to calculate limit extending to a f of x, then you have to calculate f of a. You have to see that these two things are equal or not. If these two things are equal, then we say that the function is continuous. Clear? Pause this video to take the notes. Let's go for the second problem, that is f of x equal to your greatest integer function, where this is greatest integer function and you have to calculate at x equal to 2 it is continuous or not. Clear? On the basis of definition I am solving these examples. Clear? Okay. So now this is a special type of function, that is greatest integer function. So we go for substitution method. In the previous problem it was polynomial function, which was not a special type, but here greatest integer function is one of the special type of functions. So let us go for substitution method, that is limit extending to 2 f of x equal to, that means limit extending to 2 your greatest integer x, then limit extending to limit extending to 0, you can write here 2 plus h, that means you are calculating RHL. Clear? That is limit extending to 2 plus, limit extending to 2 plus, limit extending to 0, it will be 2 plus h. As we all discussed, if this is 2, this will be your 2 plus h. It is in between 2 and 3. So the greatest integer of 2 plus h, this particular thing is going to be equal to 2. Clear? Now let us go for LHL. Limit extending to 2 minus greatest integer of x, that is equal to limit extending to 0 2 minus h. Take the value of h as 0 here. But what about 2 minus h? If this is 2, this is going to be your 2 minus h, which is in between 1 and 2, which is in between 1 and 2. So greatest integer of 2 minus h is going to be 1. So this is equal to 1. Therefore you can see that RHL is not equal to LHL. That means limit not exist. Limit not exist. For that reason we say this function is not continuous at x equal to 2. This function is not continuous at x equal to 2. Clear? Okay. Okay. Here what they are asking, show that the function f given by like this is not continuous at x equal to 0. So my dear students, please make a note that whenever they are giving that it is not continuous, LHL, RHL, f of a, in that any one of the thing is not going to be equal to each other. That means LHL, RHL, f of a. First case, these two may not be equal. Second case, LHL equal to RHL, both of these may not be equal to f of a. In this type of thing, you have to calculate both LHL, RHL. Then you have to go for the continuity definition. Have you got my point? So make sure that in this type of problems, you must find LHL and RHL. Okay students, now let us solve LHL, that is limit extending to 0 minus x cube plus 3. If I take 0 here, it will be 3. And if I solve RHL, limit extending to 0 plus x cube plus 3, again it is going to be equal to 3. If I take 0 here, this is not a special type of function, so I will not go for substitution. Directly I will put x value as 0, so it will be also 3. RHL will be also 3. That means limit extending to 0, what is your function, x cube plus 3 is equal to 3. Limit exists. But see here, f of x at x equal to 0, it is 1. After existence of the limit, we have to check f of a. Here a value is 0 because you are calculating the limit for value 0. Here a value is 0. So f of 0 is given as 1. In the function only they have given that x equal to 0, it is 1 because it is defined in two types, where x is not equal to 0 and where x is equal to 0. If x is equal to 0, this is equal to 1. If x is not equal to 0, it is equal to x cube plus 3. So for LHL, this is 3. For RHL, this is 3. That means limit extending to 0, x cube plus 3 equal to 3. But f of a, where a value is 0, f of 0, the function is given as 1. So f of 0 is equal to 1. Hence, limit extending to 0, x cube plus 3 is not equal to f of a. Therefore, it is not continuous. Therefore, it is not continuous at x equal to 0. Clear? They only have given that, show that it is not continuous at x equal to 0. So our work will be very easy. LHL is equal to RHL, limit extending to 0, x cube plus 3 equal to 3. Limit exists, but it is not equal to f of a. Hence, it is not continuous at x equal to 0. Clear? Okay students, now let us go for the next problem. Here f of x equal to 1 whenever x is lesser than or equal to 0, and it is 2 whenever x is greater than 0, and they are asking check the continuity at x equal to 0. Problem number 3 and problem number 4 are very important for your exam oriented. Clear? For that reason, you observe in third problem, here the thing was equal to 0. Here you observe it is lesser than or equal to, and it is greater than 0. Clear? Whenever the problem is given of this kind, please be cautious while calculating LHL and RHL. For LHL, limit extending to 0 minus f of x, that is equal to limit extending to 0 minus, what is your f of x for LHL whenever the function is given like this? LHL is left hand side of 0. If this is 0, left hand side of 0, that is what? 1. Clear? So f of x is 1. So your answer will be 1 for all the numbers of lesser than 0. Clear? Next, let us go for RHL. Again, limit extending to 0 plus, that means right hand side of 0. This is f of x. Limit extending to 0 plus, what is the right hand side of 0? That means greater than 0. Greater than 0, f of x is 2. So here RHL will be 2 according to your function. Clear? LHL is 1, RHL is 2. Then what is f of a? That is f of 0. See here, it is equal to 0. That means 1. So f of 0 is 1. That means LHL and f of 0 are equal, but it is not equal to RHL. That means LHL is not equal to RHL. This much is enough to say that this is not continuous at x equal to 0. So that is not continuous at x equal to 0. Clear? Please observe. LHL means lesser than term. RHL means greater than term. F of a means this equal. Clear? For LHL you should choose lesser than term. For RHL you should choose greater than term. For equal, you see where they have given equal sign while calculating LHL and RHL and f of a. For LHL directly they have given it is 1. For RHL they have directly given it is 2. So no problem. LHL is not equal to RHL. Hence it is not continuous at x equal to 0. Very simple problem. So that is limit extending to 1 minus f of x. While choosing this f of x, be careful because 1 minus left hand side of 1, that is limit extending to 1 minus, what is your f of x? X plus 2. So x value is what? 1. 1 plus 2, that is 3. Clear? Now let us go for RHL. Limit extending to 1 plus f of x, that is equal to limit extending to 1 plus, what is your f of x for right hand side? That is x minus 2. If I put x as 1, 1 minus 2 will be minus 1. Clear? So LHL is 3, RHL is minus 1. Here we choose x minus 2 because RHL greater than 1, x minus 2. Whenever x is greater than 1, it is RHL, that means right hand side. Whenever x is lesser than 1, that means it is left hand side. Now let us calculate f of a, that means f of equal to 1. F of 1, they have given it as 0. They have given it as 0. Therefore, clearly LHL not equal to RHL, not equal to f of a. LHL not equal to RHL, and that is it is not continuous. It is not continuous at x equal to 1. It is not continuous at x equal to 1. I think now you got the idea how to calculate continuity whenever the function is given this kind. Clear? For left hand side 1, x plus 2. For right hand side of 1, x minus 2. For equal to 1, this is 0. While calculating continuity, left hand limit, right hand limit and f of a terms are very important. For left hand side lesser than, for right hand side greater than, for f of a equal to. That is very important, that you have to keep in your mind while solving the continuity type of problems. Clear? Note this. Okay students, so now I will start our 4-star problems. That means what about the 4-star you already know by seeing my previous videos. So 4-star problem means you know what is the code of 4-star according to us whenever you see my previous videos. So no problem, I will start my 4-star problems. So students, be careful whenever you are watching this type of videos or this type of problems. Okay, let us see what is the problem. Find the relationship between A and B. That means we have to find the relationship between A and B, the given function. What is the given function? Ax plus 1 whenever x is lesser than or equal to 0. Please remember, lesser than means left hand side, equal to means f of a. Next, bx plus 3, that is x is greater than greater than 3. That is greater than 3. Clear? So this is our LHL, this is our RHL, and again this term is our f of a term. They have given that it is continuous at x equal to 3. That means already the function is continuous. You no need to check it is continuous or not. What they have given? This function is already continuous. I think if you know the definition of continuity, what is the meaning of continuous at x equal to 3? What is the meaning of continuous at x equal to 3 here? Left hand limit is equal to right hand limit, and that is equal to f of a. Clear? Okay. By seeing at this problem, let us solve. What will be your LHL? Your LHL will be limit extending to 3 minus, that means left hand side of 3, that is ax plus 1. Clear? So now this is equal to what? X value is how much? 3. 3a plus 1. Call this as equation 1. Clear? Now let us go for RHL. Limit extending to 3 plus that is bx plus 3. It will be equal to 3b plus 3. Clear? For right hand side it is 3. For left hand side again it is lesser than 3. So left hand side will be your equation number 2. Please remember, if you solve equation 1 you get left hand side. If you solve equation 2 it is right hand side. And they have given that it is continuous at x equal to 3. So we know that, what we know, if continuous then LHL is equal to RHL, that is equal to f of a. I will use this LHL equal to RHL, that is 3a plus 1 equal to 3b plus 3. Clear? Take 3b on LHL, it will be 3a minus 3b. Take 1 to RHL, it will be 3 minus 1, that is 2. Here 3 is common. 3 times of a minus b equal to 2. So if you simplify this, you are going to get a equal to 2 by 3 plus b. 2 by 3 plus b. So this is your required answer. That is, relationship between a and b is a equal to 2 by 3 plus b. If you solve this much, it is more than enough for complete marks in your board exam. So limit extending to 3 minus ax plus 1 is 3a plus 1, that is your first equation. 3 plus is bx plus 3, 3b plus 3, that is your second equation. From the definition of continuity, let us use this LHL equal to RHL. 3a plus 1 equal to 3b plus 3. If you solve this equation, you are going to get a equal to 2 by 3 plus b. That is your required answer. This much if you solve, it is more than enough for this. Clear? Okay students. So now let us go for again second problem. Find k for this f of x is continuous at x equal to 5. So they have given the f of x, and you have to calculate the value of k in your f of x is continuous at x equal to 5. Okay. Again LHL, limit extending to 5 minus, what is your f of x for LHL? Kx plus 1. So that is equal to 5k plus 1 is your first equation. Next let us go for RHL. Limit extending to 5 plus. For RHL what you are having? 3x minus 5. So that is equal to 3 into 5 minus 5. That means equal to 10. This is your second equation. Clear? We know that from the continuity of definition, LHL is equal to RHL is equal to f of a. Use this. LHL is 5k plus 1. RHL is 10. Clear? So k equal to 9 by 5 or 5k equal to 10 minus 1, k equal to 9 by 5. So this much is enough to write in your exams for this. Clear? Okay. Okay students, now let us go for problem number 3. In problem number 3 what they have given? Find k for f of x. Here inequality sign is not given. That means for LHL also k cos x by pi minus 2x. For RHL also k cos x by pi minus 2x. So for that reason, we shall don't waste the time for LHL and RHL. We shall directly go for limit extending to pi by 2 of the given function. That is limit extending to pi by 2 of your function. I am not wasting time here for LHL and RHL because here inequality signs are not given. That means there will be no different functions for LHL and RHL. You see in previous question, for LHL it was different function, for RHL it was different function. So we went for LHL and RHL. Clear? But here for LHL also the same function which you are having for RHL. For that reason, let us directly go for limit extending to pi by 2 f of x. So that is limit extending to pi by 2. What is your f of x? K into cos x divided by pi minus 2x. Clear? So it is continuous. It is continuous at x equal to pi by 2. It is already given in the problem, so no problem. Limit extending to pi by 2 f of x, this is your given function. How to simplify this? That is limit extending to pi by 2. K is constant, write it as it is. How can you write cos? Sine of pi by 2 minus x divided by, I will take 2 common from this. If I take 2 common, it will be pi by 2 minus x. Pi by 2 minus x. So you observe this. Limit extending to pi by 2. This term is what? Already we solved in limit of a function also this type of problems. Already we solved in 11th class also. So this will be equal to 1. So your answer will be k by 2 into 1. So that is k by 2. Clear? From again, if after getting k by 2, we know that from the definition of continuity, limit extending to a f of x is equal to f of a. This thing we know. In the previous problem, we should write LHL, RHL and f of a. But here we are directly writing limit extending to a f of x equal to f of a. So what is your this term here? K by 2 equal to f of a. That means at x equal to pi by 2, this is how much? 3. That is what your f of a. Clear? F of a means what? F of pi by 2. X equal to pi by 2, you are having 3. So that is k by 2 equal to 3. This implies k equal to 6. Have you got my point? So limit extending to pi by 2 is k by 2. F of a term is 3 from the given function, that is x equal to pi by 2. So it is 3. So you take 3, k equal to, you are going to have 6. If you get any confusions, here you can write f of a, that is f of pi by 2 equal to 3. Clear? So you take this as 2 and you take this as 1. Here you can write from 1 and 2 also. Clear? So we know that f of limit extending to a f of x equal to f of a. From 1 and 2, k by 2 equal to 3. Therefore k equal to 6. F of a is f of pi by 2. A value is what? Pi by 2. F of pi by 2 is how much? 3. Directly from your problem. So therefore you are having the answer k equal to 6. We solved 3 problems of this 4 stars. Clear? Okay, already you know what is the meaning of 4 star.